Hello, I am Altero5, and today I will explain more in detail about the new RNG manipulation method that I just released a program that allows to use this method for Pokemon Colosseum and Pokemon XD Gale of Darkness. This is the program you see right here. And I thought I'll do a video explaining exactly what happens in detail under the hood of this manipulation method. Because, in my opinion, this is probably one of the most interesting RNG manip I've ever heard of for two reasons. One, you can let me know in the comments below if I'm wrong, but I've never heard of a RNG manip that affects this much a GameCube or a Wii game. And I'll explain later why this is very uncommon. And also, the second reason is this is a very special procedure compared to other RNG manipulation. We'll go through this as I go through this video, and you'll see why this is a pretty special procedure. And it happens to work, and the fact that it happens to work is kind of insane. But I'll basically go through all of this. So, before I start, I just want to mention that basically how this came through. So, around 2 months ago, I submitted a video on YouTube that was a proof of concept with Pokemon Colosseum that I can find the current seed of the game. And this was the first huge step for this entire manip to be possible. And now, 2 months later, I have this full program that uses basically the same algorithm that you saw in this video, except with a full GUI and everything. And now, it allows to manip the starters with specific criteria that a runner may want, and it increases significantly the chance on early you'll get a run. You'll get runnable starters. On Colosseum, it was from 1 to 2% to 30%. It goes up this high. On XD, it's a bit less. It's 1 to 2% to 16%. But that's still huge. And it doesn't take that much time to do. It takes a bit. There's some step involved into this that takes a bit of time, each reset. But it's entirely worth it considering how much you gain from this. So, now that you are aware of this, I just want to mention, you do not need to know any of this if you're a runner of either of this game, of what I'm going to tell in this video. Because this program, I made it so that you shouldn't need to know any of this. I made a wizard that's user-friendly and everything, so this is only if you're interested to know what's going on. And this is also going to be a lengthy video, but I really wanted to talk about this because this is really interesting. So let's first start the game. This is going to boot on the GameCube menu. By the way, I'm using Dolphin simply because it's easier to record, but I have tested this on hardware, and from what I've seen from early testing, it does seem to work for other people on hardware. So we're not going to talk about hardware here. It's just for recording purposes so that you can see everything, because I do not have a capture card. Let's first start with basically how do you do an RNG manip. Because again, this is a really unorthodox method, so I just need to explain what you need to be able to do an RNG manip in RTA. You need three things. You need to be aware of your current seed. That's the number that generates the random sequence of numbers. You need to be able to know exactly how many rolls happened since you were aware of that seed. And you also need determinism. So you might know if you heard about tassing or anything RNG related, really, that the reality is that it's an impression of randomness. It's not actually random. There's determinism to it. Like, there's specific algorithm that if you give the same input to this RNG, you'll get exactly the same output every time. So there is determinism. It's just the way it's implemented makes you feel it's RNG, and there's so much factor that goes into it that it might as well be random for the player. So you need determinism, you need to be aware of your current seed, and you need to be aware of the number of rolls of RNG that happened since that seed. So it's completely deterministic, so you can predict what's going on, what's going to happen next. That's the point of an RNG manip. Now, usually, and this is where this becomes incredibly difficult to manip any GameCube or Wii game, usually a manip involves, well, there might be some special step that you do before. For example, usually it's setting the clock. And now on the DS, there's a thing when you set the clock and you boot the game at a specific time, and then you get, magically, you just get exactly the same seed every time. If done correctly, of course, but you get exactly the same seed. Because of this, you can predict everything. As long as you are aware how the game works, how many times it's going to roll, but this can be obtained with messing with the games inside. So, really, that's a true manip. That's what I'm going to call a really full manip. The problem is GameCube and Wii games, they will usually, I haven't seen games that don't do this, but I'm sure they exist. Usually, GameCube or Wii game, what they do is they take the value of the clock as their initial seed. So that's how they start the generator. And this clock on the GameCube, the Wii's even worse. It's 1.5 times faster. But on GameCube, it's going to tick once per 22 nanosecond. And if you're not aware of what a nanosecond is, it's a billionth of a second. And just as a comparison, right now this GameCube menu is running at about, you can see here, about 60 FPS. And 60 FPS, that's one frame per 0.02 seconds, roughly. It's a bit less, but roughly. So when I say that this is going to tick once per 22 billionth of a second, this makes the entire concept of frame irrelevant here. In fact, I even tested this, and per frame, it wasn't ticking the same amount because there was too much variation per frame. 22 nanoseconds is so small. So what I'm getting with this is you cannot aim for a specific seed. It is impossible to do so. The best you can do is, say I set the clock. Okay, say I set it at 000, and the reason I'm going to explain why this exact date later, but say I set it and boot the game as fast as possible, the best I can do is have an idea of what range that's the seed that I got was when the game is going to boot. This is the best that I can do. I cannot aim for a specific seed. And this is the case for many GameCube and Wii games. Because on GameCube, I said 22 nanosecond. You have to imagine on Wii it's even worse. Because it runs faster, meaning it's going to tick at an even smaller time than 22 nanoseconds. So it's like, good luck getting a manip on this. However, what I explained earlier, I say that you need to be aware of your current seed and the amount of roll that happens seeds. You don't necessarily need to know the initial seed. You just need at one point to be aware of it. And this is what this procedure will entail, because I'll do it now. Okay, first of all, why does it start at 0? Well, there's a value in the system. Not in the menu or anything. In the CPU, if you want. There's a value that stores the clock value, a sort of clock value, and if you set it at January the 1st, 2000 at midnight, this value will be 0. So it starts at 0 on this date and time. Say you set this clock at this time and you boot the game as fast as possible. This means, and I did tested this because I tested, and essentially this clock value is 64-bit, but the game will only use the lower 32-bit. So you need to have a range that's not exceeding 32-bit. And it turns out I tested this and it takes 1 minute and 45 seconds to cycle around these 32 bits. So what this means is that as long as you boot the game under this time, you're actually correct. You can assume a range of seeds by booting the game as fast as possible. This is how... This is huge, by the way, because a seed is 32-bit. A 32-bit, if you do the math, it's about 4 billion seed. That's a lot of seeds. In fact, it's way too much for what we're going to do. But if you set the clock on January the 1st, at this date and time, and you boot the game as fast as possible, you can reduce the range down. Let's say, for example, that you give yourself 5 seconds of margin of error, so 5 seconds of range. That's 20 million seeds. That's way better than 4 billion, but it's still a lot. And we're going to go to how we can narrow it down to only one seed, because the point here is that if we can find that seed, we're good. That will be past the clock obstacle, because all we care is to have that one seed. So how I implemented this? Well, the idea is that, and I know that I just said that frames isn't really a relevant concept here, but still, I wanted to see, because the game is still going to poll the input by once each frame. The menu does this. I know that it does it once per frame. So frames does matter for inputs, it just doesn't matter for time span for the clock. So what I did is I recorded a task of me setting the clock, going through this and pressing start. And I counted the number of frames that took, and I arrived at a certain number that I cannot get lower. And that's assuming, and I know this isn't true, but I assume that each frame, the clock will take what is the equivalent of a 60th of a second. Even though that's not true. It's just to have an idea of where that minimum time is. Because the idea is I know what is possibly the fastest you can boot the console. That's the idea. So I have this seed that you're going to get if you're blazing fast and the clock is aligned and the sun is aligned and everything is aligned to be as fast as possible. And then I say, okay, you may hit a seed starting from that number that I got, that minimum seed number that I got, plus a certain amount that correspond to a, what I call here, a margin of error. For example, here it says 5 seconds. What this means is that in real time, you can waste up to 5 seconds of setting the clock, navigating the queue menu, and booting the game. You can have max 5 seconds from wasting from that minimum frame number that I got. And if you're wondering, is 5 seconds actually consistent? From my testing and from what I seem to get, or from early testing of other people, that seemed to actually work fine. The thing that you have to be mindful of is that the longer this number is, the higher the range will be, obviously, because if your time span is longer, you're going to have more seed to deal with. But on my test, I put 5 seconds as the default because it seemed to work reliably well. sorry, on the contrary, you could decrease it and you'll have less seeds to deal with, but it's going to be harder to hit that range. The point is, I'm assuming a range that you're going to get by booting the clock of the game. So that reduces the number of possible seeds to a huge amount. So let me just do that, because this is the first step of this manip. Basically, we're going to reduce the amount of seeds we're going to deal with. So let me just put this like that. This is definitely going to work in a 5-second margin. Okay. Let me wait that this game boots while I explain what we're going to do next, because it's good. We have only 20 million seeds to deal with, potentially more or less if this margin increases or decreases, whatever. We have much less seed to deal with, but now what? Because just as I booted the game, a ton of RNG call happened. I'll say, if I'm not mistaken, I think it's about 1,000. No, I think there's more. Whatever, there's a ton of RNG calls that happen just as I booted the game. We need a way to find out our current seed from these 20 millions that we've narrowed down. Now, it just so happened, and this is really lucky, that both Pokemon Colosseum and XD has what's called a quick random battle mode, where I'll just show you. By the way, just as I entered this menu, more RNG call happened. So that's how much RNG call happened. We're probably like 3,000 to 4,000 calls right now. So that's a lot of RNG calls. But if I go here, you see I ran a random team here. Because if I go back and go here again, this is different. In fact, if you see the name, it says Thomas, but before it just said Wes. In fact, I can do it again. Yes, set now. It turns out there's 3 possible names and 8 possible teams. But here's the thing. Because you generated this, and you see the result on screen, before you accept the battle, you can basically have an idea. You can narrow down the 20 million seeds this way. So the idea is, say you have a seed out of these 20 millions, and you follow its path through all the boot up process until you get to this team generation. If that seed is a good candidate, it has to respect what you're seeing on screen. It has to. It's logical, really. It just has to respect this. But the thing is, as I just said, there's 3 possible names and 8 possible teams. So you could do this over and over throughout this 20 million seed, and then you get less seeds because some will be thrown out by this filter. Because some will not give what you see on screen, which we know are not the correct seed if that happens. So you basically just do this over and over again until you're left with only one seed that survived, if you want, all this criteria and all these roles, and they respect what you see on screen. And that's the idea of the seed finder. So let me start a prompt. First of all, because I messed up with the what's it called? The randomizer by doing a bunch of stuff. I'm just going to redo this again. Going to skip this because I literally I didn't do a precalc file. Oh, whatever. I'm going to explain while it does its thing. Okay. So the seed finder. The goal is simple. Find the current seed. That's all we need to do. So to set it up, it's as I said before. You have to set the clock. Because I tested this with the full 4 billion seed. And it takes about 30 minutes. That's just impossible. Like, I don't expect any speedrunner to wait 30 minutes to get one try and one try only. and still do a frame perfect input. That's going to I'm going to cover this later in this video, but yeah, that's pretty much the. It's not happening, so you have to use the clock to narrow down the amount of seed. Okay, so let me do this. Done. Okay. So it's really simple. It just you have to boot it fast enough. That's all you need to do. Now what it's doing right now, and I'll explain as I go through, because this method of narrowing down a range of seed does work in theory. But even with the fact that I have only 20 million seeds to deal with, even with this fact, that's still too much. I was expecting like 5 minutes. I'm not sure if I remember because it's been a while, but it was way too long. So I had to use many optimization to do this. The first that I had the idea of is the obvious one, is using multiple CPU threads. I don't know if you're aware of how CPU threads work, but in your CPU, you may have multiple cores. And that CPU may also support what's called hyperthreading. Okay, it's done. But let me explain stuff. What's called hyperthreading, which it's just an intelligent scheduling where you take your number of cores, and for each core you have 2 threads. That's basically how it works. And this allows to run stuff in parallel. So it could be doing something while it does something else. And fun fact, GPU are just made for this. It's called parallelism. GPU are made for this. They're made for parallelism. But the CPU is not too bad at it. This CPU, for example, that I'm using right now to record this, has 4 threads. So it can run in parallel for stuff truly in parallel. Because sometimes there's going to be a scheduler that is going to do stuff and there's more than 4 stuff. Whatever. Details. The point I'm trying to make is that I can do 4 stuff in parallel. Well, it just so happened that, say you simulate seeds on this. The result of whether a seed is correct or not does not depend on any other seeds. So each of their seeds can be simulated independently. You can calculate them, go through all the whole process independently. So what I did is I took advantage of this, and I basically use a library called OpenMP, which is implemented on it seems to be implemented in the compiler level. And it does all of this magically. It just spreads out the task of this seed finder in all the threads that are present on the hardware. So for this CPU, for example, on 4 threads, it's going to spread this out evenly on 4 threads. Meaning, what could take like 5 minutes will take 4 times faster. So like 1 minute, 1 minute and a half. That's a huge speed gain. And most PC today that I see have at least 4 threads. At the very least, they have 2 cores with hyperthreading, so 4 threads. That being said, yes, it does mean that this finder will perform much worse if, say, you have a Pentium with 1 thread or something. Like, you really don't want to have a cheap CPU. You just want to have a decent one. The speed doesn't matter, it's just the number of threads. Okay, so that's the first huge optimization, and honestly, I could have stopped there. But we can do better, because as we just saw here, it proposed me to generate what I call the pre-calculation file. The concept of what I call this is that this is specific only on the first pass. So the first time you enter the info. So for example, I'm about to enter Thomas and Meganium. So it can simulate all these seeds and whatever. However, there's I mentioned it earlier, but I mentioned that there's like 3,000 to 4,000 skulls that happen even before you generate the first team So what I decided is that these 4,000 skulls, I only need to run through them once. And the thing that has to do with this is that if I have to only to run through them once, I mean, I could just pre-calculate the number of rolls it will do per seeds, store that in a file externally, so I would store that on a hard drive, and that file may end up being very large. You saw it for 5 seconds, it was like almost 400 MB. That's quite a lot, honestly. And it may take a while to generate. Like we just saw, it took like about 2 to 3 minutes to generate. That's quite slow. But the advantage with it is because this is a file that's stored, and these skulls will never change per range of seed that I'm going to simulate. Essentially, you'll be left with having the number of calls already pre-calculated. So I won't even need to go through all of the calls that the game does with all its algorithm and stuff, which is much slower. Because there's an algorithm that allows me to be much more efficient if I already know the number of rolls I'm going to roll the RNG with. So that's the idea of pre-calculation, and it speeds up performance by a huge amount on the first pass. In fact, I was quite surprised because it's like about 33 to 50% performance improvement. That was huge, and with all of these optimization, this is how it does on a 4-thread CPU. It's already at 10% right now, so it's about a minute. If you have 8 threads, it's about 30 seconds, which is even better. So it's not too bad, actually. Especially considering this is the only part that's going to be slow. This is the only part that you'll be left waiting. The rest of the passes, you won't even have time to see the progression here. It's going to go too fast. So this is the idea of the seed finder, which is, in my opinion, the most interesting part of this minute. Because again, it's not every minute that asks you to do this. So again, I said that you have to do this over and over, and you can already see I have... one sec, I cannot read. 4 million results. We were with 20 million to begin with, and now I'm just left with 4 million. That's huge. And it's going to be 20 times faster, so... Basically, if I do this again... See, that was really fast. And now it's going to be even faster. On Colosseum, because of how it works, it takes about 8 passes. Let me go through this, and then I'll talk some more. West Meganium. 8,000. This narrowed down extremely quickly. Swampert. 314. West Meganium. This might be the last one. Raikou. Oh yeah, sometimes it's trolling. It's like, there's only 3 results left. Sometimes I even happen to have that only one is narrowed down from this, and it's just, oh my god. There it is, okay. This seed is 100% the correct seed. Because only one survived through all of this. There is okay, admittedly, there is a chance for false positive, but the only way for this to happen is user error. You really need to misinput the info you see on screen. Or the whole thing with the clock and margin of error, that maybe you're not in range. But for most of the time, this is not common to actually have a false positive from a misinput. So there it is, that's our current seed. And in fact, just to make sure this is correctly the correct seed, let me... if you're not aware of this, this is another one of my project. It's just a RAM search for Dolphin. And I have a file... One sec. There it is. Does it tell... No, this. Oh, sorry. This is for XD. I'm dumb. Sorry. This one. No. Okay, so we go to seed. So this is the address of the current seed in RAM, and you can see they match. So that's basically a proof that this thing got the right seed. So that's good. We have the right seed. So this was, in my opinion, the most interesting portion of this minute. You do not see a seed finder most of the time because through manip they will have a procedure so that you always get the same seed. This one, this doesn't work like this. You always get a different seed unless you're extremely lucky and you get the same seed and you have one chance in 20 millions to have this. This is actually why I display it, but the chance is very, very minimal. So you have the seed finder, and now we are aware of a current seed. When I'm going to click finish, it's going to go through the second phase of this manip. So let's first go back here. This is going to mess up the manip, but I'm going to redo everything just in complete order, but whatever. There's, unfortunately for us, a second obstacle for this manip. Because we passed the clock. The clock no longer matters now. We can bypass the clock. But there's another issue. And that is, when you start a new game, you see this naming screen. And you can see in the background there's a bunch of Pokeball that's spawning. And if you stay with it for a while, you will observe that they're basically random. Their position are random, and I even think their size might be. Yeah, it does seem like they're... Maybe it's the timing, whatever. There's a lot of randomness going on. This is bad for an RNG manip because, again, yes, you are aware of your current seed. There was determinism until you get to that screen. But when you get to this screen, it's rolling a bunch of times. So you're no longer aware of the number of rolls you're going to have. Because depending on how many input the person takes to input this is going to vary. It just so happened that with, again, a lot of reverse engineering effort that I had to do with this screen, I fully checked the code of how RNG works on this screen. And I realized something interesting. On each frame, it will roll either once or 5 times the RNG per frame. And it always consisted per frame. So basically on each frame this screen is rendered, it calls RNG at least once. Maybe 5 times, maybe once. But never in between, always once or 5 times. And after I inspected the code, I realized that the first call is to decide whether we're going to call it 4 additional times or not. There's a 10% chance that on each frame, instead of calling it 1 time, it will call it 5 times. And it's exactly 10%. This is stored in the game data and in static data somewhere. It's always 10%. Which is huge, by the way, because what this means is that if I am aware of my current seed, whether or not it does 10%, it does pass the 10% test or not, does not matter. Because I'll be able to predict when exactly will that 10% hit or not. So it's as if it really doesn't matter. I already know the seed. So I do not care when it will do the 10%. No, I will know when it will happen. So that clears this part. But it still goes it per frame. But that's the thing. Because it does this procedure of 10% or not, whatever, per frame where this screen appears, it means that for a given amount of frame that this screen is rendered on screen, I can exactly predict what seed it will be at the end of this, when the screen is no longer rendered and these calls don't appear anymore. I'll be able to exactly know what seed will be at the end of it. And it just so happened that this is at this moment that these starters are generated. So this is the part that I'm really, I want to get there. I want to get the seed there so that I can start to predict what's going to happen. But because I can know for a given amount of frame, I can just say, okay, well, let's just generate it for a bunch of frames in a row and then present the result. And you'll have to time it still, but you'll be able to know where to hit that frame. And this is what's happening when I'm going to click finish. Okay, just a little detail. They're all green because an additional feature that I've done on this program is to allow you to filter this. So for example, you can filter by IV, hidden power, type and power, nature, whatever. You can filter by a lot of filters. And if they don't match the filter, they put it red. It's just a convenient feature, but it doesn't really pertain to the manip at hand. So for on each frame, and I obviously I tested for frame perfect, and 107 frames is the least amount of frame you can do to pass that screen. So these frames, they tell the amount of frames between. Can I go back? It doesn't seem I can. Can I? Do I have a save state? One sec. I do. Good. Okay. I don't know where that save state came from, but these frames, they start at the time you press A. So, one sec. They start at the time you press A on this prompt, and they stop on pressing A on this prompt. So it starts when the run starts, and it ends when you say yes, I want this name. And so I just generated, basically for a lot of consecutive frame, this is configurable again. By default it's 10 seconds. You can go for more. The idea, by the way, is that for a runner, if they want to say they're okay to waste a maximum of 20 seconds, they put 20 here and they'll generate for 20 seconds in frames, obviously. So that's pretty much it. You have all the starters that you have for the frame you're going to hit. So IV, hidden power, nature, basically all the good stuff that you're interested in. If you want to have a run. Also put some debug info like the seed here. Trainer ID is mainly a good way to check if you hit the right frame is you just check the trainer ID. Because to have two of them that you want in a row that has the same trainer ID, is the chance is so low that it might as well not exist. It's like 1 over 65,535. Like, that's not happening. In worst case, you can use the nature with, if it's the same, good lord, you're very unlucky. But whatever. So you can quickly check if you got the right frame or not. Now, this is how the prediction works. So it just so happened that this screen is consistent per amount of frame, which allows this prediction to work. And this is where I call this a pseudo-manip. Because, as I explained many times, a true manip involves you getting exactly the same timing every time. But here, it depends on your seed that you got earlier on the finder. And it depends on, well, exactly what you want. Because, say none of these work. Not all of these are red. So, in fact, I can even show you. One sec. It's a 15 IV. Yeah, you see, some appeared red. Okay, so let's say all of them are red. You don't want this, and it will kind of suck to redo all this procedure again, because I mean, it's not that bad, but it's still bad to redo it a lot of times. So there's nothing that prevents me, because I know you seed, and I already re-engineered the calls that happen when you generate a random team. There's nothing that prevents you for just generating an additional one, and just say, well, and just say to the program, well, I generated another one. Please advance my seed, because team generation is a lot of RNG calls. I think I counted about, it's like 1, 2, or maybe even 3,000 calls. That's a lot of calls. So what I did here is I put a reroll button. So you generate an additional team. This time it doesn't matter what team is it. It is. It just matters that you generate it, and you click it, and then magically everything changes, because it advanced very far in the RNG sequence, and can do this over and over and over, how many times you want, until you get one thing that you want. So that's pretty much how this manip works. It's a result of many reverse engineering just to get how RNG works in this game. Just proving it was possible took about 2 weeks, and about, I would say, 2 months of reverse engineering, and a month of doing this GUI. So settings, this wizard, by the way, again, it was designed so that you don't need to know any of what I'm talking about, but basically that's how it works. So with that in mind, I'm just going to redo this thing, but this time with a real, what I will call a real RT environment. Obviously, you wouldn't run on emulator, but I'm doing this only for recording purposes, and this is fine. For what I'm going to do, it's good enough. Okay, 1 sec. Okay. So we need to set the clock. I'm so used to doing this, it's crazy. Like I pretty much got it consistently good because I'm so used to do it. Go to after this, I'll show XD real quick. But XD, there's not much more to tell. The only thing that changes on XD is that the team generation works very differently. The info you have is very different too, and it's actually easier for this. I'll explain a bit when I'll get there, but that's pretty much how it works. Okay, so West plays again, and then I just wait. So admittedly, it's a bit annoying that you do have to wait on the first pass to get this, and you only have one chance to hit a frame perfect input. But still, I have a virtual machine here because this program only works on Windows, and I'm currently recording on Linux. You may know this if you're speedrunning, but this is called the neon timer. You won't hear the sound. I will hear it, however. I will hear the sound. But essentially, say you want 500 frames. Where is my cursor? There it is. Say you want 500 frames. You just start it. And then it's going to do some pop. When it's cyan, it just basically, I set it to 5 signals, so it just, you get the rhythm after like 2 or 3 signals, and then you get the timing, and on the last signal you press the input. That allows you to get relatively close, actually. From my experience, it's quite good. Okay, let me finish this. Thomas, here across. I'm so lucky. Like, they happen to be the default choice. Where's multipliers? Set and A. Again, this is normal if it reduces at the same time. It just chances here, so it can happen. There it is. Okay. So I have my seed. Now I'm going to pick a arbitrary frame for the purpose of this video. Okay, 445. Just because I can, let's re-roll once. There we go. Okay. Now this is the part that's a bit difficult. By the way, I just want to mention I'm on the emulator, and this relies on the console being constantly running 60 FPS, but you're going to see it's fluctuating a bit. Sometimes it can even go as down as 55. So, if anything, I'll hit it too early. But I just want to show how it will work. So again, you're not going to hear the beep, but you can see with the cyan color the signals. So 445, and then I press enter as I press A on this, as I select the name. Okay. So I'm probably twirling this. By the way, a little thing about Colosseum. The reason I take a preset name is because for some reason, and I really do not know why, if you pop the keyboard when you say new name, for each frame the keyboard is rendered, it's going to do additional RNG call. Although it is consistent because of with that keyboard being there, the problem is that it breaks the assumption that for a given amount of frame you're always going to have this amount of RNG call. It breaks this assumption, so you cannot use a custom name. You have to use a preset name, which unfortunately is actually a little bit of time loss, but it's not too bad considering what this allows. Also, I'm prepared for this to suck, by the way, because again, this is on emulator. On console, it's much more consistent. In fact, it's even worse on stream, because when I stream with the simulator, it's like 40 FPS. It's just like, yeah, that's impossible. Okay, so let's check the turn ID. Yeah, I definitely didn't got it. 19. Oh god, am I this early? Oh god. So you see, I was like 0.5 seconds too early. But which normally this doesn't happen, but you get the idea that it's still, if you're on console, on my test I was like always within 3 frames of the target. And I even hit it 3 times, which is nice because I don't actually have any practice on this. So yeah. Now that we are done with Colo, let's do XD. And I'll just explain the little particularities that XD had. Beside the fact that I did have to reverse engineer a lot more stuff. Fortunately, however, a lot of stuff were similar between Colo and XD, so the fact that I already reverse engineered Colo RNG made that I could reuse a lot of stuff for XD, but still, a ton of it was new, and I had to take account for this. So oh yeah, oh my, I really, okay, you know what? I'm going to copy a precal file because this is insane. I'm not going to wait through all of this. Okay, one sec, because I have one ready. No, it's in source. Did I delete it? Do I have them in bin? I don't. Okay, I actually have to make it. Okay, you know what? I'm going to skip precalculation. It's going to be slower, but whatever. This is going to take too long for this video. Again, precalc, you only need to generate it once. That's all you need to do. And after this, it works for every attempt you're going to do, as long as you do not change the margin of error in the platform. On Wii, it works exactly the same way, it's just it's slower because the clock is faster, but that's all it is. That's really, the principles is the exact same. So you see, it's very different from Colo. You see your opponent's team and your player's team. And even then, no, it's actually the entire team, it's 2 versus 2. But you also see something interesting, the HP. And it just so happened that these HP are completely random. They're not static, so you have the base stat at level 100, add random IVs, just that's really random, because you have 32 possible IVs. But as if it wasn't enough, they randomized the EVs too. And in case you don't know, for every 4 points of EV, you get 1 point in stat. And in fact, it's even worse because they try to maximize the amount of EV. So they'll try to reach at least close to 510 EVs distributed randomly. So there's a lot of RNG called into this, but the point is if I enter these HP, 263, 366, 330. To have from these 20 million C, to have C's that equals exactly these HP on these 4 Pokemon, it's really hard. Like, it might sound like you're going to get this done in one pass. Unfortunately, no. But most of the time, you're going to get it done in 2-3 passes. Rarely 4 passes. I sometime, but very rarely, got it to last for 4 pass. So this is a much quicker one to do, and unfortunately, if it wasn't for the EV generation, it will actually be possible to skip the clock, because this is so fast to do this. There's much less calls done on compared to Carlo. Carlo, the reason it wastes so much call is because they want a specific nature for when they generate the personality ID. And it takes a while to get the right nature because you have 1 chance in 25 to get it. So it wastes a ton of calls to get the right nature. And there's like 12 Pokemon there. 6 for your team and 6 on the other side. Because the other side you don't see it, but it's generated, trust me. Okay. So you already see 14 results. That's much faster than on Carlo. But it's really exactly the same thing. 98, 276. There it is. So really, same principle. Name screen, nothing changed. There's one thing, however, you can use a preset, a custom name. It makes no difference if you use a preset name or a custom name. I did these frames with the assumption that you're going to use a custom name, simply because it is a time save in runs compared to using a preset name. But for whatever reason, even when the keyboard is rendered, it doesn't do additional calls. This is really weird. I wonder why Carlo has these particularities, but whatever. So, same deal. I won't going to do it because it's really the same thing. So, there you have it. That's basically all of this program does. There's a lots of code. In fact, there's about 4,000 lines of code. And that's... Oh my god, I hate when it does this. And that's basically... Like, this is just the basic implementation shared by both games. And you can see how much code is in there. This is the where most of the magic happened with the Seed Finder, and yeah, it's a lot of stuff. So, in my opinion, this is probably one of the most interesting manip I've heard of, and I'm really happy that I was able to make this project happen. Really hoping it's going to bring new possibility, because the main goal of this was for 2 reasons. One, reduce the astronomical amount of resets a runner needs to do to get the right starters. And the second is because you'll notice that just rerolling, it's so easy to do, and it's so easy to see every possibilities, that you can be more strict and not lose much, because it's so easy to see it. even with these filters that you're going to configure, and there's even a checkbox here to hide all of them, all of the red ones. So you realize that it's really easy. Say you aim for very strict result. Sure, you will take more rerolls and it's going to waste more times per attempt that you haven't even started, but still, the easy of use and easiness of seeing a possibility is there. So I'm really looking forward to the future of speedrunning either of these games. In my opinion, this might bring more people to it, but it also might bring new routing possibilities even for this game. And I really look forward to this. So that's all I had to say. Thank you for watching.